Welcome students. In today's session, we shall learn to write down the equations of motion by graphical method. We shall look into a uniformly accelerated object. The first equation of motion. Let us assume that a body is traveling with an initial velocity u and it reaches a final velocity v in time t. This is the graph representing the motion of the object. Acceleration is change in velocity by time taken. You can write it as A is equal to BD by AD, which is the slope of the graph, giving you uniform acceleration. A can be also written as AE by OC. AE can be rewritten as OE minus OA. Now we can substitute it with values of velocity. A is equal to OE is final velocity, which is u, minus OA is initial velocity, which is u. So the equation can be rewritten as A is equal to v minus u by t, which can be written as v minus u is equal to at. This is the first equation of motion. V is equal to u plus at. We shall move into the second equation of motion, taking the same graph. An object starting with an initial velocity u reaches a final velocity v within time t. You have already studied the area under the graph gives you the distance traveled by the object. The area of trapezium OABC gives you the distance traveled here. This can be rewritten as distance is equal to area of rectangle OADC plus area of triangle ABD. Now we will write down the formula for the area. Area of rectangle is length into breadth, whereas area of triangle is half into base into altitude. So total distance is written as area of rectangle, which is OA into OC plus area of triangle half into AD into BD. We can rewrite this as S is equal to OA is written as U, initial velocity, into OC is time taken plus half into AD is time again. AD is equal to OC. BD is rewritten as AT from equation V minus U is equal to AT. BD is same as AE, which is V minus U. BD is AE, which is V minus U, that is final velocity minus initial velocity. So BD can be rewritten as AT from V minus U. Now your equation stands as S is equal to UT plus half AT square. This is the second equation of motion. Let us go into the third equation of motion from the same graph. Now we will take the distance as area under the graph. The area of trapezium OABC gives you the distance traveled. We are not going to divide it as triangle and rectangle. We will take it as area of trapezium. The formula for area of trapezium is half into base into sum of the parallel sides OA and BC. We will rewrite it in the formula form. Distance is equal to half into OC is T, OA is U, initial velocity, CB can be written as OE. CB is equal to OE, which is V. So our formula stands as S is equal to half into T into U plus V. So we can rewrite it as S is equal to U plus V into T by 2. From the first equation of motion, we have V minus U is equal to AT. T is equal to V minus U by A. Now this is going to be substituted in the place of T in the third equation. So S is equal to V plus U into V minus U by 2A. Now we have V square minus U square is equal to 2AS. So we derive at the third equation of motion. Hence we have solved the three equations of motion by the graphical method. These three equations of motion by graphical method are important. You have to analyze, study and practice these three equations. Next we go on to uniform circular motion. An object gets into circular motion in this fashion. You can see the movement of the object. Motion of a body in a circular or angular path or curved path is called as circular motion. When a body moves in a circular path with a uniform speed, the motion is called uniform circular motion. The velocity changes at each and every instance. Hence, the body experiences acceleration. Velocity of a body in circular path is 2 pi r by t. Let us see the examples of uniform circular motion. Artificial satellites moving under uniform circular motion around the Earth. The moon moves in uniform circular motion around the Earth. The tip of seconds hand of a clock exhibits uniform circular motion. With that, we come to an end of this particular chapter, motion. Please go through all the problems that has been done in the textbook as examples and behind the text and refer to the problem solution that has been sent in your first class. Thank you.